But thank you for your time, and I'm really glad I have the opportunity here to talk with everybody about public safety. Public safety is a big issue, and everybody knows about it, but there's not always a lot done about it. It's usually an afterthought. So I wanted to talk a little bit about today ensuring the reliability of these public safety networks, which we all rely on, even though we may not think about it so much. So just to kind of set the stage, if you look at the number of buildings that are out there that use DAS, in-building wireless systems, it's about 200,000 buildings this year, and it's growing at a rate of about 10% per year. Now, as DAS providers, that's a good market for us, right? But when you look at the public safety part of that, it's not such a large market. Only about $550 million in spending in the US projected by 2021. So while there's a lot of reasons to do commercial DAS for commercial operators, there's not a lot of incentive to do the public safety DAS networks, which is why we've got international standards bodies and national standards bodies that really set the standards. And those are set by the International Fire Code and the National Fire Protection Agency in the US. They're the ones who define the standards to ensure that all of those buildings are getting the networks that they need so that the first responders, the fire, the EMS, the police, have the networks that they rely on because they are different from the commercial DAS networks. So while the standards bodies set the codes, the state or local authorities having jurisdiction and the government really interpret the rules and apply the standards. So what that means is that municipalities are the ones who are requiring the compliance. Specifically in new construction, when you go to get a CO or certificate of occupancy, then they'll go and check just to make the same way you've got electricity and water and plumbing and fire codes are all met. That's when the majority of these get certified. Now, failure to do that at that time may delay occupancy. Failure to maintain it may result in litigation if the fire emergency personnel get there and their network isn't working. And then failure to operate when needed may make a critical situation worse. And that's the last thing that we want to happen. But when you look at it, the systems are just like mobile phones, right? They operate at different frequencies, but they have the same issues with difficulty in receiving signals inside the buildings because, again, the RF just doesn't propagate in there as efficiently as it does outside of the buildings. So what are the ways that these are really regulated and how they're put in place there? Typically, the passive DAS system in public safety is very much the same as traditional DAS, passive DAS systems, commercial systems. Dedicated coax networks, they've got their own antennas, they've got their own amplifiers, their own networks. Usually they're not integrated with commercial DAS systems. They are designed to cover certain parts of the building and actually designed to cover more of the building than a typical DAS system. So for example, if you go into a high-rise building, maybe there's a parking garage in the basement, your commercial DAS, your operators don't care that there's not signal in there. You'll go upstairs and get your cell phone coverage. But that's a really critical space for first responders who may need to get into the basement, in the parking garage, in the stairwells, not covered by typical commercial DAS systems. At the same time, monitoring and maintenance is done separately as well. So that's a really critical issue because when you have a commercial DAS system, you know when there's an issue. People call you when their DAS is out. When you have a public safety issue, you don't know until you actually need it. So the fire codes, again, in the US, it's dominated by NFPA, and they kind of started out with, let's regulate this in around 2009. It's the NFPA code number 72, which is the National Alarm and Signaling Code. So it really started out as a kind of a fire alarm system, not so much a communication system. And in 2013, they kind of switched, the NFPA switched to their new version of the code, which moved that standard into NFPA 1221, and that's really the standard for the installation and maintenance of the communication systems. So that's where they're starting to regulate it, and then a couple of years ago they decided, you know what, we don't need it in both places. Today, as of 2016, it's only in NFPA 1221. So you can go and check out the codes. You can see what it looks like. It lists everything that needs to be done in order for actually buildings to comply with the code. Now again, that's up to the authorities having jurisdiction, the local municipalities, to enforce them, but at least there's ground rules that provide for the communication systems needed there. And one of the big things there is that there's a provision for retrofitting existing buildings. As I said, there's 200,000 buildings today. A small fraction of that, a few percent, are being built every year. So obviously, if you're not putting them in old systems, you're missing a large percentage of buildings. So that's the way this is being done. Now, when you look at it, the new regulations are really starting to focus on monitoring, but that's not exactly clear how you monitor the systems. Now, both of these two standards bodies, the NFPA and the IFC, have slightly different specifications. I've been talking about how they do it. The NFPA, you kind of see there, it's in the section 9.6, which is the two-way radio communication section, and that talks about a 90% and 99% coverage in building, which is 90% of the areas in your common space and 99% in the critical spaces where the fire department works a lot, like in the stairwells, in the basements. And they also require 12-hour backup. IFC, very similar. IFC is found more internationally and on the West Coast. And they put it in the section 510.1, the emergency responder radio coverage for in buildings. They have a slightly different requirement, 95% coverage and a 24-hour backup. But again, all of this is really subject to the local authority having jurisdiction there. There may be a fire inspector or a building inspector that comes in and say, I need it like this, I want it like that, this is what it needs to be to get a certificate of occupancy. But again, they're both very, very clear about it needs to be monitored. And that's one of the biggest challenges that exist today, and what I wanted to talk a little bit about how we're addressing that. So what is the real challenge here with these public safety systems and the DAS that we're trying to address? So the real challenge is how to monitor the DAS to ensure that it's working when you need it, and how to do it cost effectively. Again, unlike the mobile phone systems out there, the commercial systems, they're not being monitored on a regular basis. People aren't calling up to complain that they're not available when they need them. And then the way they're implemented, also very similar to commercial DAS systems, there may be multiple sources. You can kind of see the way a typical building is structured here. You see you get a lot of the sources off air with an off air antenna. That's fed into amplifiers or repeaters that may be in a closet, a fire safety area. And then that goes through your traditional DAS network dedicated to public safety within the building. But there may be several different amplifiers or repeaters that are used by different organizations. Different police and fire may have different frequencies. They may have done the same system may be put in by different system integrators. They may have used different vendors for their systems. So each of those devices has a different method for communicating its status. A lot of them have the newer systems have adopted to this by providing some sort of alarm that goes into your standard alarm panel, and that's one way to do the monitoring. But we found that a lot of these cases, those alarms come out in different ways. They communicate differently with the outside world, and it's not necessarily to the same people. One alarm could go to the system integrator, one alarm could go to the fire marshal, one alarm could go to the building maintenance people. They're not consolidated, and when you get these different RF sources in there, which you see quite a bit in these installations, you can't really keep track of all of them at the same time. So the solution we came up with was really a way to do that without disrupting your network. And there's kind of a view of that here. And it ends up being a lossless RF channel power monitor, basically. You can kind of see, I don't know, oh, the laser works. You take your existing inputs that come out of your BDAs, your repeaters, amplifiers, pass them through the system, right out to the DAS. We've developed a system that basically gives you no loss in that system, which is key to ensure that you've got the coverage you need with the existing RF design. The last thing you want to do is put a new system in place and have to redo, rip and repair all of your DAS network. What this system allows you to do is it allows you to monitor each one of those downlink signals for carrier, basically for tone. So now you can see, hey, is that system there? Is it working? And it can also monitor the DAS infrastructure network itself as well. In addition to that, what it allows you to do is take the monitors of all of those different signals and consolidate them into one alarm management system. It's one system that gives you different alarms, and it reports it all the same way. Gives you a lot of different options. As you can see here, the box connects to the Ethernet. You can connect into your local network. You can connect out to a mobile network, out to an LTE gateway or something like that, transmit signals to the fire station, the building inspector, the building owner. Everybody can get a message that says, hey, my network is not available. And then they can go out and proactively ensure that it's repaired and it's working for when they really do need it. The system that we've come up with, once you digitize everything, you can make it web-based, you can configure it, all these different alarms and settings, just as you would any other type of web-based systems. And then the alarms are via this network management system. Again, you set them. It allows you to give you the alarms that you want, monitor each one individually, different frequencies, different signal levels to ensure that you've got everything you need there. And the way that really works, we've taken a concept which is kind of a digitizing system, and what we've done is we've kind of put it all into one box, which takes RF and then digital signals and uses both of them to do this. So you see in the top on the red there, you've got 4 different RF channels, for example. The RF comes in from the left side, 94% of it goes right through to the RF output into your DAS. So very, very little loss, a quarter dB or so of loss. You barely notice the difference on the RF side of things. But what happens is that coupled energy there goes down through the blue arrow to the digital part of it there, which is in the gray box. What we've done is taken that, developed a system that'll do RF signal conditioning, and then it passes it on to a software-defined radio, which digitizes it, converts it into a digital IQ signal, and then that allows us to do a whole bunch of different things with it in the digital realm that doesn't disturb the RF portion of the DAS. Things like signal processing, analytics, again, all those kinds of things that we want to know, that we do know about other parts of our network, especially in the commercial world. Now we can do that here in the DAS public safety side of things. You've got some outputs on the side there, a web interface, an activity log, reporting. Now you can kind of monitor it in real time. You can get reports that you can show to your authority having jurisdiction that says, hey, we are in compliance, we're sure that we're doing this, and now we know that it's going to work when we need it. We proactively go out there and fix it when we need it. As an example, this is what something would look like. So across the top here, you've got 4 common bands for public safety systems in the UHF, and you got multiple radio sources. You can put them all in there. You can even use a commercial radio band as well if you wanted to put that in there and monitor this at the same time. All that goes into the box, out the other end, right into the public safety DAS network. And again, 24/7 reporting, everything's done like you would do automatically. So this is really what the system looks like in its implementation. And if you're looking for some more information about it, it's a really important way of monitoring RF networks and the public safety systems themselves. Again, this is a 4-channel DAS network with the alarms. You can kind of see a picture of what a prototype looks like there. Critically, it's designed for public safety DAS systems, and it provides compliance with all of the codes, and more importantly, it covers all of the frequency bands that are needed in those systems, and all the way up to the commercial bands at 2,700 megahertz. So that's what we have kind of positioned as a solution for this problem. In addition, if you're interested, the Safer Buildings Coalition is an organization that's designed to spread and advance policies related to public safety. It's an organization that looks at in-building codes and really helps us to define what's needed and make sure that they're implemented in there. Some of these codes, we saw that the code revisions are 2015, 2016. They continuously update them. The next one's coming in 2018 and 2019. What happens is once they get regulated, there's always a lag time between when they get implemented, so it's really important for organizations like the Safer Builder Coalition to be out there talking about them to ensure everybody knows what it is available and how to do this and what solutions are out there. So it's really important. If you look for more information, you can certainly find it there. And that's the end of the presentation that you did, Alyssa. So thank you very much for your time, and I appreciate it.
I did it faster.
Yeah, you're good.